All right, guys, on this page of the notes, what I'm doing is I'm just giving you a quick refresher on how you graph inequalities. We've done this in pretty much every chapter we've looked at so far here in Algebra 2. So again, you should be comfortable with graphing inequalities, but because we're now graphing parabolas, I just want to give you a quick refresher. Here's the way it's going to work. You're going to ignore, step one, ignore the inequality and graph the related quadratic equation, right? So it'll either be a parabola, well, sorry, it won't either be, it'll be a parabola, and then you'll just have to decide based on the inequality, will the parabola be graphed as a solid line or a dotted line? And I let you know, right, less than or equal to, greater than or equal to is a solid line. Strictly less than or strictly greater than would be a dotted line. What you would then do, right, is choose a test point. We like 0, 0 as long as your parabola doesn't go through 0, 0. I would use 0, 0 because it's easy. And then based on that test point, we'll determine whether you would shade inside the parabola or shade outside of the parabola, depending on the result of using your test point. So that's just a quick review of the way that these inequalities work, and let's jump into it by doing an example. So here we go. I'm going to first, right, remember step one, I've got to graph the quadratic, right? So step one, I need to graph. Well, graphing requires me to ignore the inequality for the moment and graph the related equation. Well, there's a couple of ways that we can do this. Like, we learned a ton of graphing methods here in this chapter. And so I'm actually going to kind of do one of each for you since I got two example problems here. So in the first one, I'm going to do it by setting up a chart. Now remember, in order to set up a chart, the very first value that goes into the chart is going to be the value of x that represents my axis of symmetry, which I find by doing x equals negative b over 2a. All right. Well, in my case, since my b is a negative 6, that'd be a negative 6. Right? My a is a negative 1. Well, the negative 6 cancel each other out, leaves you with a positive 6. So I'd have 6 over 2 times a negative 1, which would be a negative 2. And I wind up with a negative 3. So that's going to be the first value into my chart. Now I'm going to choose some values of x that are greater than negative 3, some values of x that are less than negative 3. And it looks like when I did it, I went all the way to 0. So that's going to be a negative 2, negative 1, and 0, which means I need a negative 4, a negative 5, and a negative 6. And again, this is just going to be plug and chug, right? You plug a negative 3 into the equation. Again, remember though, we ignore the inequality. You're going to plug it into y equals negative x squared minus 6x minus 7. I don't worry about the inequality until I have to decide whether it's a solid or dotted line. So plug negative 3 into that equation and I wind up getting a 2. If I plug in a negative 2, I get 1, which means negative 4. Also has to be 1, right, because it's a parabola. It'll be symmetric. If I plug in a negative 1, I wind up with, plug in a negative 1, I wind up with a negative 2, which means that negative 5 would also be a negative 2. If I plug in a 0, I wind up with a negative 7, which means negative 6 would also be a minus 7. And that should be enough points to go ahead and graph my parabola. This is my vertex. This is my y-intercept. And here we go. 1, 2, 3. 2, there's my vertex. I'm going to be at 1, let's see, negative 2, 1, negative 2, 1, but that also puts me at 4, 1. I'm going to be at negative 1, negative 2, but I'll also be at 5, negative 2, 0, 7, but I'd also be at 6, negative 7. Awesome, now all I have to do is figure out, is my parabola a solid or dotted? And of course, since I'm strictly less than, it's going to have to be a dotted line. So I'll do my best to draw a parabola with a dotted line. That's not terrible. Yeah, I'll take it. Dotted line. And now we choose a test point. Well, let's go with 0, 0. Since my parabola doesn't go through 0, 0, that's going to be a great one. And all I have to do is plug a 0 in for y, plug zeros in for my x's, and what I wind up with when I do that is 0 is greater than a -7. The question is 0 greater than a -7? True or false? Well, of course, that is a true statement. Well, because my test point is on the outside of my parabola, and it gave me a true statement, I'm going to shade everything on the outside of my parabola. It's going to be everything in here. Shade, 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 shade. Just keep shading. Just keep shading. And there we go. So I have just solved my quadratic in 2 variables by graphing the quadratic and shading the solution region. Let's try another one. This time, instead of setting up a table, I'm going to use that method we learned where I simply put it into vertex form and graph it using vertex form. Well, in order to do vertex form, I'm going to need to complete the square, which is going to require me the use of parentheses since I can't work on both sides of the equal sign because it needs to stay y equals. So I got to do all my work on the same side, and parentheses will help me do that. My leading coefficient is a 1, so I just have to add b squared over 4 inside the parentheses, which for me, my b is a 2, 2 squared would be 4, 4 divided by 4 would be a positive 1. So I'll add 1 inside the parentheses. But to maintain equality, I'll subtract 1 on the outside of the parentheses. How about a plus 3? X, x. It'll have to be a plus 1 and a plus 1. All right, so I have an A of 1, an H of 1, and a K of 3, which means I am going to shift left 1 and up 3. Left 1, 1, 2, 3. My parabola is going to open up, and it'll have a standard shape over 1, up 1, over 1, up 1, go over 2, up 4. 1, 2, 1, 2, 3, 4. And my parabola needs to be a solid line because it is strictly less than or equal to, it is less than or equal to, so it'll be a solid line. And once again, 0, 0 is going to work. So I plug in a 0 for y, 0 for x, 0 for x, and I wind up with 0 is less than or equal to 4, which is a true statement. Well, since my test point is on the outside of the parabola, that means I will shade everything on the outside of the parabola because my test point gave me a true statement, right? 0, 0 is a solution. So everything outside of my parabola would be a solution. So we'll shade everything out here, which is a lot of shading. Yes. There we go. Just keep shading. Just keep shading. Shade. And awesome, there we go. I have now graphed my quadratic in 2 variables and shaded my solution region. That takes care of all the problems on this page of the notes. Head on over to the next page of the notes and we'll take a look at the second objective, solving a quadratic inequality in 1 variable, where now what you need to do is find the solution interval. So I'll see you on the next page of the notes.